If a projectile is fired with velocity v sub 0 at an angle theta, then its range, the horizontal distance it travels in feet, is modeled by the function r of theta equals v sub 0 squared sine of 2 theta over 32. If v sub 0 equals 2200 feet per second, what angle in degrees should be chosen for the projectile to hit a target on the ground 500 feet away? First, we rewrite this equation and substitute the given information. Specifically, v sub 0 is 2200, and so we would rewrite it. Instead of v sub 0, we write 2200, and don't forget to square it. We only substitute v sub 0 with 2200. Everything else must be the same. This equation will give us the range, the horizontal distance, and it depends on the angle theta. We want to find theta where this range is 5,000 feet away. To solve this equation, we first need to isolate sine of 2 theta, which is 5,000 times 32 over 22,000 squared. This is not one of those special angles on the unit circle, but that's fine. We will use inverse sine. 2 theta equals sine inverse of this expression, 5,000 times 32 over 2200 squared. Before we isolate theta, we will write 2 theta, or we will solve 2 theta for a reason that we will see. Sine inverse of this number inside the parentheses is 1.8944 degrees. And so theta equals 1.8944 degrees over 2, or 0.947 degrees. If the projectile is fired at an angle of 0.947 degrees, then it will hit the target on the ground 5,000 feet away. However, there is another angle that satisfies this condition as well. We only obtained 1.8944 as the result of sine inverse because every time we use the inverse function, we are only guaranteed to obtain one answer only, because inverse functions are one-to-one. And sine inverse is restricted to the first and the fourth interval, or from negative 90 degrees to 90 degrees. The angle that we found is 1.8944 degrees, not 0.947, but 1.8944 degrees, because this is the result of sine inverse. And yes, this is 2 theta. There are infinitely many angles 2 theta, such that sine of 2 theta will give us 5,000 times 32 over 2200 squared. Not just this particular one. There is another angle in the second quadrant as well, and that angle in the second quadrant is 180 degrees minus 1.8944 degrees, and this is 178.1056 degrees. And yes, this is 2 theta, and so theta equals a half of 178.1056 degrees, or approximately 89.05 degrees. And if we were to picture this, we see that if we fire the projectile and we want to hit the target on the right hand side, for example, then as long as we fire the projectile at an angle of less than 90 degrees, then it will move to the right, or the projectile will fly to the right hand side. We need to stop at 89.05 degrees, even though we know that there are infinitely many 2 theta that will give us the same result. We need to stop at this angle because if we were to keep going, then we would pass 90 degrees. But if we pass 90 degrees, we would need to fire the projectile to the left-hand side of the target. And so in summary, if we want to hit the target 5,000 feet away, then we would need to fire the projectile at either 0.947 degrees or 89.05 degrees. Either of these 2 angles will give us the desired result.